Alright, so now let's talk about wrappers, or wrapper classes. The wrapper classes are classes that represent the primitive types like int and boolean and char, but as a class. So here we have the 8 primitive types laid out, and then their corresponding wrapper classes. So really, the wrapper class is just the primitive type with a capital first letter, because most classes are named like that, save for the char and int, which are character and integer, their full name. And remember that classes are places to store related variables and functions, so that can kind of give you a hint as to why we would use wrapper classes, is to access some special variables and functions that we couldn't access otherwise with just a primitive type. And remember, we've seen classes before with like the main class that we create from the main method and the string class that we just learned about. To use wrappers is pretty simple. It's just like their primitive counterparts. You just say the type, space, the name you want to give it, and then equals some value. So here we have the integer wrapper. You just say the type, which is capital I integer, give it a name, equals 5, some int. And then just like the primitive counterpart below here, we would say int primitive equals 10. Looks very similar. Another thing that's cool about wrappers is that you have access to pretty much everything that you can do with a normal primitive type. So like the plus equals operator here, we can use that for integer wrappers, and you can even do wrappers like integer wrapper plus another integer wrapper, or you could do integer wrappers plus the primitive int as well. So now int wrapper would be 15 because we added 10 to it. So why do we want to use wrappers if it's basically just a fancier version of the primitive type? Well, for one, it allows conversion to and from strings, which is super useful for a lot of string manipulation. Also, it is required for some more complex objects that we'll learn later, like array lists, which require a class type. So if you want to use like a primitive type like an int, you can't use that for these complex objects. You'd have to use the wrapper, which acts like an int, but it is an actual class type. It also lets us use the maximum or minimum value of a type, like integer.maxValue gives us the maximum int value that we could possibly have, which is like 2.1 billion. And then lastly, if you want a variable to be able to be null. And if you haven't heard of null before, null is basically like no value. So a normal primitive int doesn't have any way that you can represent no value whatsoever. If you don't initialize it, an int is going to be set to 0, but 0 is still a value. You can say if an int, you can check if an int equals 0, but if you want it to have no value whatsoever, you can use an integer, the wrapper, because classes or objects have the ability to not be able to not point to anything. They're just absolutely no value whatsoever, which we call null. So now wrappers sound pretty awesome, right? It's just like primitive types but better. But actually, you really only want to use primitive types, or you only want to use wrappers for those 4 reasons that we talked about before, because the wrapper classes are very inefficient with memory and speed if you don't use them properly. So really just always use the primitive types wherever you can, and just stick to these 4 reasons here for using the wrapper class. Alright, so one of those reasons that we talked about was converting to and from strings, and this is how you do that here. So I'm just looking at some examples of wrapper classes, just like the integer, character, and boolean, but this same kind of pattern applies to all of the wrapper classes that exist. So to go to a string, you just say the wrapper class dot to string, and then in parentheses either the primitive type like an int or the wrapper type, so you could convert an integer into a string. And that's the same for every single wrapper class. And then for almost every single wrapper class, going from a string is pretty similar. You do the wrapper class name dot parse and then the wrapper class name. So parse integer or parse boolean, parse float, whatever you're working with. And then in parentheses, it takes a string. And from string is going to spit back out the wrapper class type, or it might just be the primitive type like an int, depending on how you catch that value. And then the toString is going to spit back out a string for you. The thing to be careful with for converting from strings is if you have an invalid conversion, like if your string is hello and you're trying to convert hello to an integer, Java doesn't really know what you mean by that, and so it's going to give you an error and that's actually going to crash the program. So you got to be careful with parsing from strings. Also, you can notice that the character wrapper class is a little bit different here. And we've seen the char@at function before, and that's actually how you would convert a string into a character. You just get the first character, so char@at index 0, because remember indexes start at 0 for strings and arrays. And that's how we would convert a string that's one character long into a character, or we could use the char@at to get any character in a string to convert it back into a char. And then, of course, if you forget any of these, as long as you're not in like a practical, you can just Google up convert blank to blank in Java, and it should give you the syntax right here. All right, and so lastly, how do we compare equality of wrappers? So just like strings, because the wrappers are a class, you cannot use the equals equals operator. Instead, you have to use the dot equals method, just like the strings use. So down here we have an example of character wrappers, and we're using the dot equals function to compare if they're equal. And that is about it for wrappers.